a solution that has more hydrogen ions than hydroxide ions.
Are there different types of acids?
Funny you would ask. There are.
What are they?
There's an Arrhenius acid, and there's a Bronsted-Lowry acid. Arrhenius acids are acids that simply donate a hydrogen ion to the solution, whereas the Bronsted-Lowry acid donates a hydrogen to the solution, while a Bronsted-Lowry base simply takes away a hydrogen from the solution, therefore decreasing the hydrogen concentration.
That is so neat.
I know. How neat is science?
The neatest.
Hey Spencer, what's all this pH hubbub about?
Well, the pH, Tanner, of a solution is the negative log of the concentration of the hydrogen in the solution.
Neat. What's pOH?
The pOH is the negative log of the concentration of hydroxide in the solution.
So what would you get if you added the pH and the pOH together?
You would get 14.
Oh, neat.
Hey Tanner, is there such thing as weak acids and strong acids?
Funny you ask, Spencer. There are.
What's the difference?
A strong acid is an acid that completely donates all of its hydrogen ions to the solution. A weak acid is an acid that donates only a portion of its hydrogen ions. Whoa, how neat is that?
The neatest. What is the Ka?
A Ka is the acid equilibrium constant, usually used for a weak acid.
What is the Kb?
A Kb is the base equilibrium constant, used for weak bases.
What happens when you add Ka and Kb together?
That's a stupid question, Spencer. Nothing happens. Please ask a different question.
What happens when you multiply Ka and Kb together?
Funny you would ask, Spencer. When you multiply a weak acid's Ka by its conjugate bases Kb, you get the Kw.
What's the Kw?
Kw is equal to 10 to the negative 14th power, and you can use it to solve for weak acids conjugate bases Kb, or weak bases conjugate acids Ka. Whoa!
That is so interesting.
I know, how neat is science?
The neatest. Hey, is it true that acids dissolve things?
I don't know. Let's see. Let's go.
Okay.
So here we have hydrochloric acid, sulfuric acid, nitric acid, and acetic acid. These are the objects which we will dissolve in acid. This is concentrated nitric acid, which we will be pouring over a bullet. Here, the nitrate ions cause the solid copper to oxidize and go into solution, creating nitrogen dioxide and water.
Here we are going to pour concentrated nitric acid over a sponge.
As you can see, not much is happening, so we're going to add sulfuric acid. Here, the sulfuric acid is reacting with the cellulose in the sponge. Here, we will pour sulfuric acid over a cheeseburger. The sulfuric acid successfully decomposes the lipids and proteins in the burger. First, we added acetic acid to the cell phone and cell phone battery.
When very little reaction occurred, we decided to pour nitric acid over the phone battery.
We then added sulfuric acid to the solution. Here, the ions are causing the solid metal to go into solution. We are now pouring sulfuric acid over an apple and pieces of graham cracker. Here, the sulfuric acid dehydrates the fructose from the apple. We will now pour nitric acid over an old shoe. Not much reaction is occurring, so we added an old t-shirt. We will now pour sulfuric acid over a foam finger. Not much reaction is occurring, so we will now add nitric acid.
This is what happened when we added a key containing mostly copper and zinc to the sulfuric acid solution containing the bullet that had stopped reacting.
Now time for cleanup! Ew, that's real gross.
I think somebody should neutralize that.
Maybe if we had like a weak base or something, we could neutralize it so that we don't harm all the animals and stuff.
Wow, that's really bubbly.
Yep, that's what happens when you add sodium bicarbonate to acid and water. It bubbles.